Welcome back. Today, we watch a craftsman turn rough-hewn oak into a precise structural frame, blending heavy timber with delicate joinery. Removing the uneven bark edge establishes a true reference line. Without a perfectly straight starting plane, every subsequent measurement would compound the initial error. A jigsaw then shapes a curved profile at the end. Rounded forms eliminate sharp corners that tend to splinter under daily use. Moving to the next phase, a custom-built jig controls a plunge router to carve evenly spaced slots. Precision here is absolute. Freehand routing can wander along the dense grain of the oak, ruining the piece. By securing the tool within a track mechanism, the builder guarantees uniform depth and spacing across the entire run. This consistency is the foundation for interlocking joinery later. Trimming the stock to its final dimensions requires careful feed rates. Guiding the oak across the router table creates a chamfered profile along the edge. Removing sharp right angles reduces the chance of edge damage and gives the massive timber a lighter visual weight. Clamping the workpiece vertically into a metal jig exposes the end grain for shaping. End grain is notoriously stubborn, requiring sharp tooling and steady pressure to avoid tear out. This pass creates the male portion of a joint, designed to seat tightly into the corresponding slot. A bandsaw removes the final waste material, leaving behind a delicate star-shaped lattice. By the afternoon, the focus shifts to internal channels. A deep groove routed along the length of the board will soon house the decorative panels. Stopping the cut before the end of the board hides the joinery from the outside. An application of gold-colored finish adds a layer of visual contrast to the wood. Sanding immediately afterward forces the pigment into the recessed grain while leaving the high spots bare. Cutting a continuous profile along a large panel requires keeping the board flush against the fence. Any drift away from the guide bearing will result in a wavy edge. The spinning bit shears away the excess material, leaving a perfectly uniform contour. Finger joints drastically increase the gluing surface area compared to a simple butt joint. The interlocking teeth distribute mechanical stress across multiple faces. To create them, the craftsman secures the board into an indexing jig. The router bit cuts a precise notch, and the jig shifts over exactly one blade width for the next pass. The tight tolerance is critical. If the spacing is off by even a fraction of a millimeter, the joint will either refuse to close or fit too loosely to hold glue. A dry fit confirms the machined tenon slides into the mortise with just enough friction. The connection holds fast. Shaping the primary load-bearing legs starts with a rough jigsaw pass. Because the blade tends to wander in thick hardwood, the cut intentionally stays outside the pencil line. A handheld router then cleans up the face, bringing the wood down to its final smooth curve. This two-step process, a clean finish, without burning the wood. A biscuit joiner plunges semicircular slots into the mating surfaces. The compressed wooden biscuits inserted here will swell upon contact with water-based glue, locking the panels in perfect alignment. The decorative lattice panel is coaxed into the main frame. Using a wooden mallet prevents bruising the oak fibers during assembly. The interlocking grid must slide in simultaneously to avoid binding the structure. Driving the heavy leg components into their mortises locks the base together. At this scale, the joinery relies on substantial surface contact to resist the racking forces of everyday use. Every strike seats the shoulders firmly against the uprights. A power drill bores a precise housing for custom hardware. To complement the heavy oak, the craftsman turns a solid brass bushing on a metal lathe. Brass is an ideal bearing material. It machines beautifully, resists corrosion, and will eventually develop a natural patina that matches the warmth of the wood. The cutting tool shears off microscopic ribbons of metal, bringing the cylinder down to an exact diameter. A tight interference fit means the bushing will press cleanly into the wood without needing adhesive. The finished brass seats perfectly into its cavity, creating a durable pivot point that wood alone could not provide. A final routing pass chamfers the exposed edges of the upright posts. This protects the wood from impact damage and makes the structure comfortable to the touch. With the glue applied, the massive armrests drop into position. Their custom cutouts are designed for function, but their thick profiles contribute directly to the rigidity of the entire seating frame. An orbital sander removes any dried glue, squeezes out, and levels the joints before finishing. Driving screws into the oak seat, slats, is the final mechanical step. A right-angle drill attachment accesses the tight clearance beneath the backrest. The finished bench is heavy, solid, and built exactly to tolerance. What started as an uneven log is now a unified piece of furniture designed to outlast its maker. The natural grain remains the focal point, while the hidden joinery and brass details ensure its structural integrity for decades to come. The work stands ready to serve.